I want to give a talk about writing better APIs. And I titled this talk, So You're Writing a Framework. And then I actually realized that that wasn't really the correct name for the talk, because it doesn't matter if you're writing a framework. It can also be that you're writing a feature, or writing an API, or a library, or even a code base, or maybe even most importantly, and probably something that matters, or at least we are really interested in, when you're writing an app. And like I said, I think most of us can relate to this. I think most of us have been writing or have been working on an app, and if not, we'll hopefully do so soon. And it's really important to think about how you're writing that to make it sustainable and make it work in the years ahead. So who am I? I'm an iOS developer at Xing. Is there anybody who knows Xing here in the room? A few. So Xing is a German company. I work in Germany, and it's a social network, mostly like for finding a job, and it's only operating in a German-speaking market. So I don't blame any of you that didn't know. I work in the platform team there, and that's one of basically the team that works most on the underlying layer of all our frameworks of our app. So imagine something like a UIKit wrapper or a foundation wrapper, or how we use core data and interface with it, even though we have all these teams within the company that build their own part of the app. They normally don't have to care about the nitty-gritty details of what's below, and we try to build that API layer. So that's a bit of my background on why I wanted to give this talk. Other than that, I curate a newsletter called Swift Weekly Brief. That's actually bi-weekly. Funny story. But that's an update on what's been happening in the Swift.org and all the Swift open source projects every other Thursday. I do some open source things. I've been working on a few libraries. I've been working on some tooling. It's interesting. And I actually like continuous integration systems too. That's what I've been working on the last year in the company, doing internal tooling, working on continuous integration, as well as the release management of our apps, both iOS and Android. So that's a bit of who I am. And I want to begin by asking you all some questions. Have you ever tried using UIKit without documentation? And Xcode actually sometimes helps. Anyone? Like, good. I'm happy. Nobody did. Because you don't want to. There is great documentation in UIKit that helps you understand how to use it and where to use it and how not to use it. Have you ever tried using someone's undocumented API without looking at the implementation? Oh, wow. I'm so sorry for all of you. Of course, we don't always have access to the source code. But if there is really no API, I don't want to be you. I don't want to use such an API. I think when we look at open source, it's pretty nice because especially some most libraries and some tooling is documented because people expect or want other people to use their tool and then think this documentation can help, and well, they are right. Have you ever tried using an undocumented API you wrote in the past without looking at the implementation? I also feel sorry for you. But that obviously, how can that happen, by the way? Because we all write documentation, right? Oh. So, do you remember the last time you refactored something, and what was the reason? Maybe it was because you didn't understand the code. Probably it was. I mean, you obviously want to make it better, but you don't just want to make it better if you understand the whole thing. I mean, then it's probably good enough. And to introduce this whole topic, I want to start with a real life example. I like looking into like pull requests that just end up in our. We have a mono repo, so we have a big repository of our iOS app, and I like just going through pull requests to get a feeling of how are other people in the company, how are the other developers working on the app, how are they coding, what are they working on. Then this was another code base actually, and I was looking into a pull request that came up in my GitHub notifications. I was subscribed or like watching that repository, and this is what I found. It was a work in progress at lists class, and I was like, I have no clue what this means or does, and there was no description at all. So there was really nothing to start with. And while there was code. So I looked at the code, and yes, it's Ruby. I'm sorry. I told you I like continuous integration and tooling or whatever, so I've been working on Ruby as well. There will be Swift. And this is actually part of our continuous integration tooling that we use Calabash as a framework for UI tests. And we have a wrapper that makes it easier to use this framework either if you're working on iOS or on Android. There are some weird differences between the two. And looking at this code, I mean, we have this array 1, array 2. I had no clue what this was doing. So right, yeah, anybody with any idea what's going on? Probably not. Me neither. So there's only one way to find out, and that's asking, can you explain what this does? Can you give some reasoning behind what you wrote or what it's supposed to do? And this is what I got back. And I don't want you to read all of this because it's a lot. So I just want to focus on a small part. Is this pull request adds a possibility to concatenate arrays without removing the duplicates in the parts that are not overlapping completely. Still unsure? No, this is understandable. Come on. No, I wasn't sure either. And it's like, it sounds like an interesting idea. What are you using it for? When are you using it? Give some more context. But at least we started with adding some documentation that doesn't get rid of this awfully named array 1, array 2, but at least starts to explain what those variables mean, what they are used for. And then after that, a unit test was even added. So that actually gave me the first idea of like, hey, I feel like I have an idea of what this wants to do. And I have some examples basically that can verify my assumptions. So I was indeed expecting we have some kind of initial array from A to C, A, B, C, a second array that partially overlaps C, or what is it, like C, D, E, and we want in the end we want one array that says A, B, C, D, E and removes those duplicates. So we had a first idea of what was going on, and we had a test, so it wasn't not testable. So that was a good thing, I guess. A different colleague with more Ruby experience then joined us. He was in the same team, and he continued with the pull request because we had the feeling that it could still be improved, and it could obviously, and he worked on it. So this was now the new class. The whole file that was before about 50 lines of code, which wasn't that much, but it was 50 lines of not understandable code. And now it is about 25, including those header documentation comments. And it is more understandable. But still, there was something that bothered me. And I think at this point, the pull request was actually merged. And there was still something that bothered me, and that's something we're all familiar with. Naming is hard. Because we had this concatenate without overlap, and it felt really verbose. I mean, it's Ruby, but it felt like Objective-C. And I mean, I knew what it meant, what it did, and what it was meant to do, but I also felt that the next person that would see this code would probably not understand. And then after this pull request was merged, the colleague actually pushed to master. You should never do that. With some improvements. And they were actually improvements because what he pushed to master was only documentation. And he added this example and edited this documentation saying, prepends an array to front of an existing one. And gives this example of like 6, 3, 2, 1, 6, 5, 4, 3, and it returns from 6 to 1. And that's exactly the opposite of what we actually wanted. So as it turns out, the implementation we just saw was wrong. There was a bug in it. It was tested, the tests were green, but it was wrong. And this example was actually really nice to figure that out. And then we sat with the three of us and saying like, I think this is wrong. This is not what we wanted initially, was it? Because honestly, I wasn't entirely sure. And then we figured out, hey, that was not what we wanted. So we went back and we sat with the three of us for like half a day, and it was a great day. It was really nice was a really nice feeling to be able to change this and feel good with it. We changed the example so that it actually did what we were expecting to. And then we came up with a name that I was really fond of, even though it might not like explain the whole thing at first, but it was stitching. Because what I was realizing is you have these apps in the App Store where you take multiple screenshots of a long web page, for example, and that app then stitches it together. And I was like, that's perfect. Like, that's exactly what we're doing as well. And the documentation is there to help. So we have a name that we like. We have the documentation to help. There are tests. Happy days. And then this was the second part where we do this check if the array starts with another array, and that's like only used as an implementation detail. I'm actually not sure if this was private. It should have been. But basically the result was 3 happy people. Or at least I was happy, and as far as I know, the other 2 were also happy. What we learned, or what I learned, is pair on a problem. And if you're not able to pair, at least write down what you're trying to do, or try to share it with a friend, or try to share it with someone on the internet. And it doesn't have to go into detail, but try to have some way to bounce ideas off of. We learned new things. We learned that it's not as easy to actually write an implementation if you have a spec, especially if the spec is not ideal. And it's also really easy to introduce a bug or to have a misunderstanding. And as it turned out, it was really hard to actually figure that out, because I didn't figure it out until we actually had this example that told us. Good thing, though, was easy to fix by ways of actually adding a new test that failed, and then we could fix the problem, and everybody happy. Hopefully the code is understandable. I think we did our best in this case and felt like this is something we feel comfortable with, like giving over to someone else to continue working on. In a sense, what I experienced was the following. We started with code, and that's maybe not always the correct thing, but we started with the code. And the code was there, was improved because it wasn't ideal. We have the code. Then we wrote the tests that verify all the business logic in this implementation. And we had tests, and the tests were green, and everybody happy. And then we wrote the documentation or the header documentation to understand, hey, what is it that we wrote? Is it doing what we expect it to do? And anybody can read these intentions. So to repeat that, We start with code. Then we have tests. And then we have documentation. Code, tests, documentation. No, these are not three separate devices. At some event, somebody said this. I realized, and probably I felt like it was too late that I really realized these three coming together. They're like a Venn diagram. And if all of these three parts come together, you get this end result that is satisfying and probably really thought about. And that also means that probably that it makes it easier for somebody to continue with that in the future. That somebody could also be you, like we saw earlier, where maybe you start over with your app after 3 years because you want to make it run on the Mac. Fair warning, there might be a potential unpopular opinion ahead that I might have already slipped through the cracks. I think the order doesn't matter too much of tests, code, and documentation. They can be interchangeable. But do definitely figure out what is the best for your team. And there's a high chance that starting with writing tests is a good idea. It's hard on iOS, I think. But you don't have to fully go into test-driven development. What you can also do is at least write down the test cases that you want to work on later. So you can just write those as comments. Hey, I want to test this scenario, this scenario, this scenario. Then write the implementation. But I think that as long as you keep these three things together, the order does not have to impact the end result. So the most important thing is that there is a common understanding in the team or in the company, and that the three aspects always come together in one package. But the question still remains is, how do you measure the success of such a thing? How can you then, after you're done using this three-step method, know that it was a success? And what I came up with is it is successful if a failure or success case that is discovered or added in the future can be solved via test-driven development. So that means in what we had this bug, and we could actually fix it by introducing a new unit test that would fail, fix it, and it would be green. The thing is, I'm not happy with this. It is only measurable after the fact, really, and that sucks, to say the least, because we don't want to write a piece of software and then only later on, when we have to refactor it or when we have to add some business logic, figure out if we did the correct thing. And that brings me to the following that I also want to, that I always want to stress in my talks is communication is hard. And this really is something that I try to remember more, quite often, because everything we do, in the end, is about communication. And the problem we're trying to solve always is communication. And the way we do that is by managing expectations. And also this is far easier than it actually is. It sounds a lot easier than it is. I think what can help reach these goals, or at least to make it better, is as a team or as on whatever level, create a vision for what you're working on. This can be in a team, this can be for a feature that you're working on, it can be a refactoring that you're doing. What is the goal? What is the thing you're trying to achieve? You want to define a scope so that you don't have the baggage of everything you don't want to work on now. And that's really tempting, actually. Just recently, we had a really funny bug in our app. Probably some of you know about the Candy Crush bug. where you can't log in if you set the device time differently. We had that bug. We fixed it, and it was a one-liner. But then we were like, hey, this code doing the whole login is not ideal. So we started doing some refactoring and refactoring and refactoring, totally out of scope. And that, in the end, introduced a new bug, obviously. It wasn't me, it was the colleague. We had to fix that later. So define a scope so that you don't get lost in the details or lost in things that are not important for the problem you're trying to solve at that point. And then lastly, iterate, iterate, iterate. Make sure that you can iterate, and don't be afraid to write the not so perfect code in the first place, but actually work through that as a process, which is what we saw just now. Maybe the initial code wasn't really good enough, should have been better, but we saw that we had this unreadable code, we made it better, we added documentation, and we came to a good end result. So with this in place, we can still improve, and we always can. So it's also not an ideal silver bullet anything, no way. But we want to get better. So let's look at a little Swift in a bit, actually. But before that, what more can we do? I think one of the things we saw is give an example in a pull request overview, in a header documentation, in some other documentation that lives outside of the code, so that somebody that stumbles upon it can more easily visualize what the problem is about and what it's trying to solve. Write simple, and I didn't like this word, but I didn't come up with a better name. It's non-linear code documentation. So that's not header documentation, but actually something, think of like an architectural design decision, and make sure that that is documented and that it's, make it at least as easy to find as possible. That's also sometimes hard. We have a lot of documentation, a lot of teams, a lot of GitHub repositories, and sometimes you get lost in, hey, where can I actually find this thing? No raw loops is an advice given by Dave Abrahams at WWDC, where if you have just a loop somewhere that isn't abstracted in some kind of algorithm, some kind of named loop, maybe rethink that. It's probably like more important at a lower level than at a higher level, but if you're using a loop, think about it. Try to build an API that has self-enforced best practice. Make sure that you aren't able to write code that you don't want. One of the examples is static string. It's a type in Swift that can only use a string that is known at compile time. So it's not a string with interpolation. That's not allowed. So that's one of the ways you can self-enforce this best practice. Think about a strongly typed API where, again, I think this pretty tightly couples to the self-enforced best practice where you can't input a type that is not expected. Again, think of the scope. And one of the last things is compassion. I think it's always important to be aware of what's the human side of this, and how can we, in the end, make our lives happy? How can we make a code base that makes us eager to work on it? And that can be in various ways, from pull request reviews to how to write a style guide. And then lastly is I don't know, there's lots of things, and I'm pretty sure that all of you have something to add here, and I'm sure they're all wonderful ideas, so definitely think about it and see what else we can do. Okay, so I told you about a little Swift. Not yet, we're almost there. I want to talk a bit, give a bit of background before I dive into the Swift code that I want to show, and that is a component system. So at Xing, we have what's called a component system. which in the end isn't much more than just UI views that have some pre-configured details so that we have some kind of cell that has an image and has some text. And with that, what we want to avoid or what we want to foster is that anybody building a part of the app can use these components and be reasonably certain that the whole app still looks relatively similar versus when they would just build any view. And this component system or design system is obviously backed up by designers. So this is something that the designers are aware of, or actually they started this whole thing. And so we work together with the designers to come up with new components if necessary. And what we then added was a component configuration or text configuration, because the problem that we were trying to solve, or that we're having still, is we had like 1,000 of those components. Component 116, component 117, and that 117 would have the headline bold, for example, like a really small change. And that all had to sync up with the designers, so yeah, that didn't really work out because it took a long time to actually get this number because it couldn't collide with any other number, and it was not ideal. And we realized that we have these strongly typed colors. We have these colors that are our colors and are expected to be used in this component system, but there was really no way to. So we came up with a configuration for that. That configuration has strong typing, as we will see. It also has Objective-C interop, because half the code base of us is still in Objective-C. But that might be a good thing, because it makes you think, like, hey, what are we taking for granted? What are the features of Swift that we maybe not be able to use, and how can we either like do that in another way or like improve the API across both platforms, both programming languages. So here is Swift. Looks a bit like Swift. So we have this text configuration, which is an NS object because otherwise no Objective-C. And we have this initializer that takes a color, that takes a text width, a size, and a number of lines. And what's missing here? Documentation, documentation. So let's add some. So we add this documentation that tells us, hey, this creates a new text configuration with these specified values. Maybe a bit overkill because probably you were able to guess that. But it also tells you about the parameters and what they actually mean. So like a text color, well, like if I see the type text color, it's like, okay, I'm not really sure what this is and what is expected of me. So we explain. The text color to use, available colors are a subset of the Xing color and are safe to use for text. One of the last things is this number of lines, and this was actually copied over from Apple's documentation because probably like, most of us are aware of this. If you set number of lines to 0, it means like there's no end. You can have like 70 number of lines. But I felt like it would be nice to repeat this here because essentially you're not interfacing with the number of lines API from Apple, so one that sees this might not know. So we add to remove a maximum limit and use as many lines as needed, set the value of this property to 0. So then we create one of these header configurations or these text configurations that we just saw. And we do this with a color. This is how our colors are called, with a font weight and a font size. And you can see that these are like strongly typed. And one of the things that's missing is these number of lines because there is actually a second overloaded function or an overloaded initializer that defaults this number of lines to 0, which would have been easier in Swift because you can use a default expression, but we couldn't. But now that we have this, what do we do? This is a bit hard to read probably, and a bit much, so let's zoom in a bit. This is, okay, I have to actually go back. So we have this function that from a UI label returns the text configuration. So if we already have an existing label, we can actually extract this text configuration out of it. So this is the meat of this function, where we actually check if we can do that. Because like we've seen before, we have these text colors. And if you have just some label, I mean, we're not able to disallow anyone from setting anything they want. But if they do, they can probably not, like, they cannot work with this text configuration, because it's like we can't create an instance of this configuration with invalid values. So what we do is we check if this text color is actually available. So this color that was used for the label. If not, we use an assertion. And I can't stress enough, use assertions. I actually have a blog post written on this. It's in the references at the end. Assumptions are your friend and not your enemy. Really, if you have this else case where you say, it's never going to happen, or if you have this guard that just returns and no-ops part of the bug that we fixed, by the way, use an assertion and just crash, especially at least when developing. Just let yourself know that this is not expected behavior. So we do this here. We do this for the color, for the weight and the size. And if that's valid, and we go back, we can actually return an initialized configuration. And then if we're not on debug, we default to some default values, which, I don't know, maybe we should crash, who knows. So then we have a function, this is the end of the function where we actually return a new text configuration. I use this .init. It's actually really a really neat little trick instead of text configuration, because if you now want to change this name of text configuration, and obviously your Xcode refactor does not work, the code will still compile. And that was actually what happened, because I renamed this this text configuration a few times and it bothered me, so I changed it to that. Last thing before we can show how to use this is this apply function. So if we already have a label and we want to give that a whole new configuration, we need to, it would be nice to do that. And there were two ways to do this. You could actually do it on an extension of UI label, but I figured out let's keep that namespace clean and do it via the configuration. It's nicely documented, and it returns the UI label actually, so that you can then chain some API or at least have a reference to that label. And it has this @discardable result, so that Xcode won't warn you or bug you when you don't actually use that return value. So now we can use it. We have our header configuration that we get from this header label somewhere else. And let's assume that this was a valid label that we can get a text configuration from. And now we have this subtitle. And what we can do is we get this header configuration. We have some helper functions that I didn't show earlier that sets the color to a different color. So instead of creating a whole new object, you can simply do that via this. And obviously, we can do the same for the text size and the number of lines and the text weight. And then we use this apply function that we saw just now to apply to the label. And now the subtitle label is properly configured with a configuration that we expect, or at least that we tolerate. It might still look ugly, who knows. And we have tests for everything. All these functions that we've seen return a new object. And that's really nice, because that means that these functions are basically just a mathematical function. It goes from, you put in A, you get out B. If you have that, it's really easy to test and verify that the outcome is what you expect. As well as what we're seeing now is, hey, we can say this was at least some sort of success, because we can plug in like a failure case or a bug, and then via a test case, fix it and be happy. So the outcome of this was the API was scoped. We have the text configuration, and it doesn't do anything else than configuring the text. Maybe and applying the label, which like you can maybe like ask if that's the right thing to do. Like I said, we could do it on label as well. I felt that this was the better place to do it, but there's not much room for anything else, and that's by design. It's testable, plus the fact that bugs and edge cases were fixed and covered during development. We have Objective-C interop. Again, for us, like we had to, like there was no reason, like there was no option to not do this, because then we could only use this API for half our code, and the whole like basic implementation of components, or maybe like mostly all of it, is Objective-C. So then we couldn't even use it at the core, which would like didn't make sense. We have a chainable API that is easy to extend and to work with if you like want to do something more with such a configuration, and you can edit it. It's not perfect though, and that's okay. And I guess I'm saying this more to like defend myself. But like I said before, like there is no silver bullet. There is no like optimal solution. And also like the architectural design that we might have thought about, but not really, could have been written down. Like, hey, how did we define the scope, and what is the goal of this like configuration, and maybe even why did it come to life? Why did we even think about this configuration? Because we hadn't had it for quite a while before, and that's also what I've been telling. But it is in a state where somebody can improve and change it with confidence. So that's a good thing. Outcome part 2 is more about the code. Like the compiler is your friend, and use that. With that being said, don't be afraid to use types. We have this. We don't use a UI color. We use a different type that, in the end, is like holds a reference to your UI color. But that means, in comparison to the old implementation, we can't just easily like miss this API and use any UI color instead. The compiler is also your enemy, like we've seen with this .init trick, or where the compiler just doesn't tell you, hey, this will work in Objective-C or won't work in Objective-C. Yeah, just be aware that Xcode is not always ideal. We should explain this architectural design. Like I said, it's really something I feel that can help a future like improvement on this whole thing. Like, of course, somebody can work with this API and extend it and change it, but actually like make a different decision of like, hey, let's get rid of this configuration, or let's really expand this configuration. That would like really require such an architectural design where they can reference how to do that, or why the decisions were made in the first place. Prevent the rest of the damn all syndrome, which is like, for those of you that haven't seen it, I wanted to add a picture, but it didn't really work. Is like you have 2 circles. That's step 1, and step 2 is you have the whole thing, like really nice and whatever. So make sure that the API is understandable and has like similar building blocks that are not of really different sizes, and obviously part of it is also header documentation. Use assertions. Make sure that if anything you don't expect, just crash. It's fine. Some more things to keep in mind is, and I wrote this in the I sentences because I feel like it's really something that I feel. I don't want to write the correct code. There is no correct code. There is no silver bullet, but I can at least try, and I can at least think of how I'm writing the code and why I'm writing it. the way I am. I want to help the most correct code to be written. Again, there is no correct code, but I want to allow myself, and in the future others, including myself, write code that is understandable. I want to prevent incorrect code to be written. Think about a strongly typed API. Think about like using types and preventing any type to be injected. I want to fail early and often. Again, assertions. For that, I do need it to be testable, because then if we fail, we can actually like implement a new test that verifies it and then has the correct behavior again. And again, make sure that there is room to iterate on what you built. Some takeaways. Optimize code for reading and not writing. Like, it's really tempting to write a really beautiful API, but try using it after as well. See if it's readable. And keep in mind that code is far more often read than that it's written. Because you read it, you read it, you read it, you refactor it. You read it, you read it, you read it, you refactor it. It's really something that you need to keep in mind. Work together if you get the chance to, and bounce off ideas with other people. There's like always like such a high chance that you aren't on the same line, and you have different opinions, and you have different ways of making what you're working on better. Documentation is helpful for yourself when writing code too. It's not only something that you do because somebody else might interact with it, and that's a really good reason. But in the first place, it can help you create better naming in the API and create a scoped function that actually does what you want it to do, and maybe before it did too much. So it can help you with naming, it can help you with the scope, it can help you with testability, and can help you with readability. Having testable code feels awesome. Like really, if you don't have testable code, and that's like the last thing, and I didn't talk about this, but I had to include this one, snapshot tests. Who's using snapshot tests? They are the worst. Because yes, they can be useful for refactoring, but more often than not, you have non-testable code, or you have this 1,000-line massive view controller, and you think, I can't test this. But wait, I can create a screenshot, and if that fails in the future, something changed. And it actually also fails when every Xcode update comes around, and ugh. Don't talk to me about this, I don't want to talk more about it. Thank you.